All right, so today we're taking a look at place values. Now, place values are used to let you know exactly the value that a digit holds when you see it in a whole number. And when we get to decimals, you'll see it there as well. So it will always tell you the value that a digit holds where it is. Now, with the inclusion of zero with our natural numbers, and therefore we have whole numbers, which is the unit we're talking about, we're able to display a number that has zero of a certain place value. And you can tell the difference between, say, 10 and if I write just 1, because otherwise you would just see just like 1 and nothing else. So with 0, it helps us actually be able to see a difference between these numbers. Now, our place values are as follows. We start with our first place value of a 1, known as the ones place. Um, and this is the ones place because when it first were counting, you only have one digit, right? And as you move up from there, like when you go 9, the next number is 10, you start over again with the 1 in front, and in the 0, now in the 0 now in the ones place. And then you add 1, 2, 3, 4, 5, 6. So that repeats as it did the first time until you get to the next set of 10. And so these place values always go up based off of a set of 10. And so that's why we have our ones place, and then we get our tens place. And then when you have 10 tens, you reach 100. So our hundreds place. And when you get 10 of those, you reach our thousands place. And so this became a new classification. So we had our group of ones, now we're in our thousands. Well, when we get 10 of those, we just call them 10,000s. When we get 10 of those, we call them 100,000s. And then we reach a new classification, which is millions, which literally actually means 1,000 thousands. And so we get our millions place, and then it continues there 10 millions, 100 millions, and then we get billions. And then our next classification after that is trillions, and then quadrillion, and it just keeps going and going and going. And these numbers can go on forever, as we talked about before. Whole numbers you can just continue to count up. Now, with these place values, though, so say for instance, in this case, I look at my 6. That 6 is not just the number 6, it actually represents 600,000. And so knowing our place values allows us to better understand what value our numbers hold. So in this case, this number written here is 87,654,321. And I can read that number accordingly. Now, another cool thing is when we get the exponents, it'll be even easier to see, um, is that each of our place values is just a power of 10. As we said, as you get a set of 10, you can move up to the next level. Well, that's because each of these place values is based off a power of 10. And this will be very useful and helpful in understanding when we get to decimals later. But our ones place is 10 to the 0 power. That is because anything to the 0 power is going to be 1. So remember that for later, with the exception of 0 to the 0 power. But any number other than 0 to the 0 power will just be 1. Because how many of those do you have multiplying? You have none of them. So it just must just be 1. Because 1 times anything has to be itself. So we get 10 to the 0 power is our ones place. 10 to the second power is 10 to our first power is our tens place. 10 to the second power is our hundreds place. And these, of course, make a lot of sense. Because when you take a look at this, when we get to our tens place, we have 2 digits now, right? And 10 to the first power, you have 2 digits. When you get to the hundreds place, 10 to the second power is 100. You have 3 digits there, and this has 3 digits as its numbers to represent its total value. And so that is place values. So place values literally tell you the value of the place your digit is in. So again, we go ones, tens, hundreds, thousands, 10,000s, 100,000s, millions, and 10 millions.